In problem number 16, the directions say, what is the inverse? And as a reminder, to find the inverse, we're going to start by switching the x and y. So switch the x and switch the y. Now, what is this e that we see? E is actually Euler's number, and Euler's number is used often when we model real-life scenarios. You'll see it more as you move into physics and into upper-level mathematics. So E is a number, and if you're thinking to yourself, like, what kind of number is it? It's irrational, like we see the pi symbol. So if I hit the blue key and I go straight down, I will see E. So E to the first is approximately 2.718, and so on. Okay? Just like we know pi, pi is approximately 3.14, right? So it's another irrational number, and it's often used to model real-life scenarios in math. Okay, so think of this right now not as a letter or a variable, but as a number. So the first thing I do when finding the inverse is to switch the x and y. And now I want to isolate the y. So I need to start by getting rid of this log base e. Using the property of logs, the inverse property of logs, I take whatever the base is and make it base and exponent. Whatever we do to the right, we must do to the left to keep the equation balanced. So this is a base, exponent, base, exponent. Sometimes students think, what are you doing, like base, exponent? Okay. Now on the right hand side, I have 1 times y minus 7 equals e to the x. Distributing by 1 doesn't change anything. And now to isolate this y, I'm going to add 7 to the other side. When you add it to the other side, it does not go into the exponent position. It's at the same level as the number e. And lastly, when I look at this problem, it was y equals. So I need to denote this as the inverse by putting this little -1 in the exponent position. So the inverse of this function is e raised to the x plus 7. Let's look at the next problem. ln, and you're thinking, what is this ln? ln, another way to write ln, is log based e. It's like a shortcut. Kind of how we have different key functions on the keyboard where you can hit shift and hit a specific key and it's a shortcut to doing something, like a shortcut to printing. Well, a shortcut to writing log base e, and I know we're only saving ourselves 2 different letters here, is writing ln, known as the natural log. So again, in this problem, the directions are to find the inverse. So I'm going to start by switching the x and y. And I want to isolate the y. So what's furthest from the y is the 2. I'm going to move it to the other side by subtracting. And just like we did now with our previous problem, which was 16a, to eliminate this log base e, I'm going to put down whatever this number is, the number e, Euler's number. I do it to the left and to the right to keep it balanced. Y plus 4, and yes, this equals 1, and multiplying by 1 is not going to change anything, so y plus 4 equals e raised to the x minus 2. Now our last step to isolate the y is to move the 4 over. Opposite of adding is subtracting the 4. When it subtracts over, it does not go into the exponent position. It's at the same level as the number e, and then this original equation was y, denoted as the inverse.